still gives us an answer of 1.25 rather than truncating and giving you an answer of 1 or giving you some weird 1.00 answer. The nice compiler converts the integer 4 to a float of 4.0 without bugging you. Now, let's talk about the order of operations in Arduino. The order of operations is the same as the order of operations in arithmetic and algebra, with one little exception. Now, some of us may remember math teachers in middle school giving us a handy little mnemonic, which is a memory aid for remembering the order of operations. And the mnemonic is, please excuse my dear Aunt Sally, or PEMDAS, P-E-M-D-A-S. At least that's the one I was taught. And I'm going to stick a graphical representation of it up here and put it up here for a minute so you guys can see it and follow along with me. So just like algebra, any term in parentheses comes first, regardless of the operation. Then things get sticky, and I'm just going to leave this up here for a minute again while we talk about it. So here's a second caveat of arithmetic in Arduino that will make watching this video worthwhile. Arduino does not have an exponential operator, at least not directly. Arduino does, however, provide the power POW function for that purpose. And let's do an example real quick. So if I type something like this, I get 3 raised to the second power. We have two arguments here, 3, the number we want to raise to a given power, and then here is the power we want to raise it to. So let's go ahead, upload this, and take a look at what we get. And here we see we have 3 squared, or 3 raised to the second power, which means the same thing, equals 9. And it's giving us a correct answer. Now, if you type something like this, and this tries to set the variable c to b squared, and it fails big time. Tries to set variable c to b squared, and fails. So this statement tries to set the variable c to b squared, but the problem is it doesn't work. So this kind of notation here you might see on certain types of calculators. It might work in other programming languages, but this will not work in Arduino, so don't do it. Let's go ahead and comment that out because it won't work. Just wanted to put that there for demonstration purposes, but writing it this way does work. So moving on. Another caveat that many of us are already familiar with is that multiplication and division in algebra, and also C programming, have the same level of precedence. The same is true for addition and subtraction, though multiplication and division have a higher precedence than adding and subtracting. So, using the order of operations in C and Arduino, an expression like this sets variable e to 10. And let me put that extra space there. If instead we were to write something like we would be setting e equal to 11 because the junk in the parentheses has a higher precedence and evaluates first. It doesn't matter whether we choose to do the multiplication or the division first. In either case, the answer remains the same. And let's go ahead and demonstrate this. And look, here I got an error. I got so excited I forgot to assign a data type to E. So let's fix that. Now it should work. And it's going to go through our first few examples real quick. And here we see we get 2 different answers for integer E, depending on where we put the parentheses or if we include them or not. There's yet another operator holding equal ranking with multiplication and division in Arduino. Some of you may not have even heard of it. If you're a programming veteran, you're likely familiar with Modulo Division. If you're new, you may not have heard of modulo or modulus division, and it may seem a bit weird. Therefore, I'm giving it its own section here because this lesson assumes you're new to Arduino. When you were first learning long division in grade school, you may have been using modulo division, well, sort of, without even knowing it. For example, you may remember doing a problem like 7 divided by 4. The answer is 1 with a remainder of 3. Perhaps later you learned how to get the more exact answer of 1.75 using long division, though both answers are technically correct. The modulus operator is used in integer arithmetic. It gives a remainder that results when the integer to its left is divided by the integer to its right. So, for example, 13 modulo 5, and let's type this up here. Int, and let's call it this time f equals 13. And the symbol for modulo division is a percent sign, by the way. 13 modulo 5. Okay, and sets variable c equal to 3 because 5 goes into 13 twice. Okay, just want to throw a comment up there so you guys know what we're doing. And let's print the result out. And I'm going to comment out some of these old lines of code because we don't want to go through the same things over and over again. Okay, let's upload it and see what we get. Oh, here we can see that 13 modulo 5 is indeed 3. Now, don't try to use this operator with floating point numbers. It won't work. And to prove it, let's do a few quick examples. Oh, and by the way, you could also use it with whole number data types like integers, bytes, longs. But I'm not even going to bother trying to do a printout. Let's just try to compile it. And see right away the compiler gives us an error. And it gives us a lot of cryptic nonsense. But the reason we're getting this error is because we're trying to use modulo division with a floating point or 2 floating point numbers. Okay, so don't do it. Let's comment that away.